I'm going to be doing chapter 4, number 50, and it says, a 2 kilogram block is held in equilibrium on an incline of angle theta equals 60 degrees by a horizontal force F applied in the direction shown in figure P4.50. If the coefficient of static friction between block and incline is 0.300, determine A, the minimum value of F, and B, the normal force exerted by the incline on the block. So here's our free body diagram. We have the incline of 60 degrees, and then we have a 2 kilogram block. And then this is our positive x, and this is our positive y, which is also tilted 60 degrees. We also have a force here. So first we have the normal force, which is going directly perpendicular to it. And then we have the weight going directly down, which is equal to mass times gravity. Let's draw the triangle to find the x and y values. So because this is 60, this angle will also be 60. And this will be W sine 60, and this is going to be W cosine 60. And then next, we have this force. This force is not in the x or y direction, it's actually going in its own direction. So we have to go find the x and y values of it. So let's draw another triangle. And because it's 60 here, this is also going to be 60. And then this will be F sine 60, and this side will be F cosine 60. And next we have friction. Friction is opposing it. Because this block wants to go down, this friction will be pushing it up in this direction. So this is friction equals mu times the normal force. Now let's write out Newton's second law. Sum of all forces in the x direction is equal to the force cosine 60, this, plus the friction minus the weight sine 60, which is this. And that equals mass times acceleration in the x direction, which equals 0 because it's at equilibrium, so it's not moving anywhere. So that equals F cosine 60 plus friction is 0.300 times the normal force minus 2 kilograms times 9.8 meters per second squared sine 60 equals 0. And then F cosine 60 plus 0.300 times the normal force equals 16.974. We brought that over there. And now let's go to the y. That's going to be the normal force minus F sine 60 minus W cosine 60 equals mass times acceleration in the y direction equals 0. So we have n minus F sine 60 equals, bring that over there, 9.8. And then that's n equals 9.8 plus F sine of 60. I wrote that like that so that I could put this n into this equation. So you have F cosine 60 plus 0.300 times 9.8 plus F sine 60 equals 16.974. And then cosine 60 is 0.5. F plus 0.300 times 9.8 plus sine 60 is about 0.866 F equals 16.974. And then you have 0.5 F plus 0.3 times 9.8 is 2.94 plus 0.2598 F, which is 0.3 times 0.866, equals 16.974. Combining like terms, you get 0.7598 F equals 14.034. So F equals about 18.47 newtons. So that's your force. Now we need the normal. So you have, going back to this equation, 18.47 cosine 60 plus 0.300 times the normal force equals 16.974. So I just plugged in F for this equation. And then that gives me 0.300 N equals about 7.712. So then N is going to equal 25.71 newtons. And that's your answer.